Work energy power. It is very important topic. And the problems related to work energy power, they enhance the thinking data, especially in physics. Probably you may get 1 or 2 questions in main exam. Before going to questions, let us take some important points related to work, energy, and power. Now, how we define work? Yes, work ఎలా define చేస్తాం? Work is said to be done when a force F is applied, the body displaced by S. Then we are taking work done is nothing but the product of displacement and the component of this force along this displacement. What is the component of force along this displacement? F cos theta. This is very important point. Our work done equal to F dot S. When we are discussing about work, just we have to consider only the force which is along the displacement. That is important. If there is no force along the displacement, work done by that force is zero. Always we should say work done by a force. Work done by which force? It is important. The force. For example, if I take one simple example, a person is carrying some weight and he is walking along horizontal direction. Now, if I ask, what is work done by gravitational force? Yes, what is work done by gravitational force? The displacement is along this direction. Any force, any gravitational force is there along the direction? So work done equal to simply zero. Or I can say the gravitational force is along this direction. The displacement is along this direction. The angle between these two is 90 degrees. So work done is Fs cos theta. So you get this is zero. Why? Because cos 90 is zero. Work done by gravitational force is zero. Can I say in this example, network is zero? Is this person is not doing work? Yes, he is doing work. Network is not equal to zero. He is working to overcome frictional force. He is doing some work. That is, if theta equal to 90, the work done is zero. This is zero work. Suppose if I take theta equal to 0. Theta equal to 0 means if force as well as the displacement both are in the same direction, the work done is Fs cos 0. Then the work is maximum. Cos 0 is 1. Similarly, if displacement is 0, then also you get work done is equal to 0. If I take one more example, suppose if a body is moving along a circular path. Now, what is the work done by the centripetal force? Centripetal force is along this direction, and the displacement is along this direction. The angle between them is 90. So work done by the centripetal force is 0. Without thinking this also, suppose if the body starts at this point, again come to the same point, then what is work done? In this case, work done is 0. Why? Because if it comes to the same position, work done is equal to 0, S equal to 0. Always when we discuss about the work is by which force? That is very important. While doing the problems also, we have to concentrate on that sentence. Work done by which force? This is important. Similarly, can work is negative? Yes, it is possible if theta equal to 180. That is, if your applied force and displacement both are opposite to each other. For example, if I take one case, work done by frictional force. What is the direction of frictional force? This is the direction of frictional force when the body is moving along this direction. In this case, theta is 180. So work done equal to minus Fs you get. Why? Because cos 180 is minus 1. That is, work may be positive, work may be negative, work may be 0. And very important thing, in one case you get work may be positive, work may be negative. For example, if I take another example, an object of mass m. This is lifted to height h. To lift this, I applied some force here. This force should equal to gravitational force. In this case, what is work done by force? What is the value of F? F equal to mg. Here, force and displacement both are in the same direction. So, this is positive. Suppose in the same problem, if I say work done by gravitational force, ademautundi cheppu? The gravitational force and displacement both are in opposite direction. So, work done by the gravitational force is negative. So, when we are doing the problems, work done by which force? Work done against which force? That point is very important. Okay, work done equal to Fs cos theta, or work done equal to F dot S or Fs. Can we apply this always? Here one constraint is there. When this force, this does not depend on displacement or this is constant, then only I can apply this. Or work done equal to F means M into A into S. This also you can apply. For example, if force depends on displacement, that is displacement, then for example, let us take, I am taking one spring. The force constant of spring is K and restoring force is Kx. Now, if a question is asked, what is the work done to compress the spring from x is equal to 0 to x equal to x? That means here the displacement is x. Simply, can I take work done equal to force into displacement, kx into x? This is equal to kx square. Can I write like this? No, I cannot write like this. Why? Because here force is dependent on displacement. So in this case, what I have to take? Using integrals you can do. That is work done equal to, in this case, I have to apply the formula F dot dx. F dot dx is the work done to compress by dx. And this x is from 0 to x. Then what I get? Work done equal to kx dx integration 0 to x. If you do this, you get it is half kx square. Suppose you don't know integration. Then how to do this problem? Yes, here we have to take work done equal to average force, because force is not constant. Average force into distance. Now what is average force here? If x equal to 0, force is 0. If x equal to x, the force is kx. So average force is nothing but kx plus 0 by 2 into displacement is x. The same result I am getting, half kx square. Okay. And another important thing related to the work is a path function or point function? Is work is path function or point function? Path function means which depends on the path. Point function means which depends on initial and final positions. How we define work is path function or point function? I am taking two examples here. For example, an object, it is lifted to height h along this path. What is the work done in this case? mgh. The same thing. I am taking a smooth inclined plane where object is there. I want to lift this to this height. This height is h. Here, what is the work done? Suppose if I take this is theta, this length is L. Now, with which force it slides? Do you know the components? How we can divide? Where mg weight is acting along this direction, it can be split into two components. If this is theta, mg cos theta, this is normal to the surface, mg sin theta, parallel to the surface. Suppose I want to move this object from here to here. How much force I have to apply? The minimum force against the gravitational force, mg sin theta. Now here you tell what is the work done. The same thing, you take force into displacement, mg sin theta into L. Again, from figure, what is the value of L sin theta? Sin theta equal to h by L. So I get h is equal to L sin theta. Then what I am getting? Work done equal to mg. You see here, if you move the body along this path or along this path, work done is same. Now your work is a path function or point function? Yes. Here work is a point function. Suppose in the same problem, if I take this surface is not smooth. It is having some friction. In this case, what is work done? Work done equal to F. Is this friction? What is the frictional force? mg sin theta is sliding force. And then frictional force. Suppose I am applying same force mg sin theta along this direction. Because of friction, the body will not move. The frictional force is acting along this direction. Now, what is the net force we have to apply? mg sin theta plus frictional force. What is frictional force? Mu mg cos theta into L. Now you observe this. In first case and the second case, work done is not same. Here it is a path function or point function? Yes, here it is a path function. Finally, the work done is a point function under conservative force fields. This is very important. Conservative force fields means gravitational field, electric field, magnetic field. In all these cases, work is a point function. And it is a path function under non-conservative force fields. Conservative forces are the forces which depends on displacement. Non-conservative forces does not depend on displacement. Now, how we can define conservative force field or non-conservative force field? Based on work, these are defined. For example, I want to move a body from A to B and B to A. Suppose if I want to move the body from A to B and B to A, the total work done equal to 0. That is, this is positive work and this is negative work. Then it is called conservative force field. That is integration of f dot dx over a closed curve. That is again A to A. If this is equal to 0, then I can say it is a conservative force field. The work done, your work done from A to B plus work done B to A. This should be 0 at the conservative force field. If this is not equal to 0, the work done along a closed curve not equal to 0, then it is called non-conservative force field. Example, sir? Yes, frictional force. Okay. Now, the important points related to the work done is the important formulas related to work done. Work done equal to Fs cos theta. This is for constant force. Work done equal to integration of F dot dx. This is for variable force. And already we know energy. Do you know what is energy? The capacity of doing work is called energy. Work and energy both have same units. What is the unit for work? Newton meter or joule. For energy is also the same units you can apply. Energy in nature we observe in so many forms. Energy can be converted into one form to another form. But the total energy in the nature is constant. You can convert electrical energy to mechanical, mechanical to electrical, thermal to electrical, thermal to mechanical. Now in this topic, we are concentrating on mechanical energy. Again, mechanical energy, it is in two forms. One is potential energy, kinetic energy. Now what is potential energy? The energy due to position or the energy to give that position. Or this is nothing but work done to give that position. మీకు ఎప్పుడు పొటెన్షియల్ ఎనర్జీ అనగానే చాలా మంది ఎంజీహెచ్ అని గుర్తుంచుకుంటారు. ఎంజీహెచ్ మాత్రమే పొటెన్షియల్ ఎనర్జీ కాదు. పొటెన్షియల్ ఎనర్జీ అంటే వర్క్ డన్. వర్క్ డన్ టు గెట్ దట్ పొజిషన్. దట్ ఈస్ పొటెన్షియల్ ఎనర్జీ. ఫర్ ఎగ్జాంపుల్, I want to lift an object from surface h is equal to 0 to h equal to h. Now, what is work done in this process? Work done is nothing but force into distance. Force, how much force I have to apply? Yes, which is equal to weight of the body. So work done equal to mgh. Potential energy of this body is equal to mgh. Similarly, I want to compress a spring. What is the work done to compress the spring? Half kx square. This is nothing but potential energy stored in the spring. In general, Potential energy means, you remember this, integration of F dot dx. This is for variable force. And this is nothing but potential energy. Here minus or plus, it depends on the field. For example, in gravitational field, what is the potential energy? Gravitational field is always attractive. Therefore, potential energy is minus, like that. Even on the same basis, you can define the potential energy in electrostatic field, the potential energy in magnetic field. Similarly, kinetic energy. What is kinetic energy? The energy when it is in motion. When this body is moving with velocity v, the work done to stop this body, this is nothing but kinetic energy. And the kinetic energy is given by half mv square. The important relation between this work and energy is the another formula for work we can consider. Work done equal to change in potential energy. If potential energy is changing. Work done equal to change in kinetic energy. If kinetic energy is changing. If both are changing, work done equal to change in total energy. For example, if a body, it is lifted from height h1 to h2. Already we know that at height h1, potential energy is mgh1. At height h2, potential energy is mgh2. Then what is the work done? Change in potential energy, mgh2 minus h1. Similarly, I want to compress a spring from x1 to x2. What is the potential energy? What is the work done? Change in potential energy of kx2 square minus kx1 square. An object is moving with velocity u. After some distance, it gets velocity v. Then what is the work done? Change in kinetic energy. That is work done. Change in potential energy, change in kinetic energy, change in total energy. Similarly, if I take one more problem. This is a table. Some chain of length L, mass M, hanging. 1/nth part of the chain is hanging. I want to put this chain onto the table. What will be the work done? This total should be put onto the table. What will be the work done? ఇక్కడ మనం ఏం కాన్సెప్ట్ తీసుకుంటాం? Change in potential energy. Generally, we know that the potential energy is mgh. So, what is m here? Total chain mass m అనుకుందాం. Now, 1/nth part mass is m/n g. Now, what is h? H means how much height we are lifting. To lift this chain, if you lift above the center of mass, it is enough. So, what is it? The total length of the chain L we consider. This hanging part is L/n. So, how much height you have to lift? L/2n. So, what is the work done to put onto the table? mgL/2n square, like this. Have you understood? Similarly, I give one more problem. I have a cube. The mass of the cube is m. The side of the cube is a. Now I have another cube. This is also mass m and a is the side. I want to put this cube onto this. like this. Then what is the work done? M, yes, about the center of mass, we consider. From this center of mass to this center of mass. What is the height? How much height I have to lift? A only. So work done equal to mga. Then suppose I have n such cubes. I want to arrange one on another. Then what is the work done? N unnai. Then it is n minus 1 into mga. Is it correct? Is it correct or not? Yes, it is correct. And another important concept in work for energy is the problems related to conservation of energy. The total energy of the system always remains constant. It can change mechanical to potential, potential to mechanical, potential to kinetic or kinetic to potential. Already we studied it. For example, if I consider an object is at H, the potential energy it has, kinetic energy is 0. When it comes to ground, all its potential energy converts into kinetic energy. According to conservation of energy, you can write mgh is equal to half mv square. Similarly, when a pendulum is moving at mean position, it has kinetic energy only. When it is moving to this extreme position, all kinetic energy converts into potential. Again, potential to kinetic, kinetic to potential. This concept is also important. In between, you take any point. It has both kinetic and potential, but all energies are equal. Here also all energy, all total energy at any point is same. This concept, conservation of energy, problems related to conservation of energy is also important. And another important relation you should remember while doing the work for energy problems. Kinetic energy. What is the relation between kinetic energy and momentum? K equal to P squared by T. And related to this formula, generally the problems will be asked like this. If the momentum is increased by 20%, what is the percentage of increase in kinetic energy? Here, kinetic energy, if the momentum is constant, it is inversely proportional to mass. Suppose if momentum is increased by 20, what is the percentage of increase in kinetic energy? To do this problem like this, you try to do this problem. Just you can write K1 by K2 equal to P1 square by P2 square. In your problem, it is given momentum is increased by 20. To solve this type of relations always, convenient way, you take initial momentum is 100p, final momentum because it is increased to 220 is 120p. So initial kinetic energy you consider it is 100k. Then 100k divided by k2. This is equal to 100p divided by 120p whole square. These two will get cancels. And pp also gets cancels. Finally, you get 100k divided by k2. This is equal to 100 divided by 12 square is 144. Finally, what you get? K2 equal to 144k. Initially, kinetic energy we consider 100. So, what is the percentage of increase in kinetic energy? Yes, 44%. Now, if the percentage is more, 10%, 20%, 30%, you do like this. Not only this, you take any relation in physics. You try to solve this type of problems like this. For example, in the same problem, he asked to find if momentum is increased by 2%, what is the percentage of increase in kinetic energy? 2% is very small. ఇలాంటి కేసెస్లో మీరు ఏం చేయాలంటే k equal to p square by 2m or k proportional to p square. Differentiating both sides, delta k by k proportional to 2 delta p by p. Now, momentum is increased by 2% means delta p by p into 100 is equal to 2. So what is delta k by k into 100? 2 into 2. So what I get? 4%. Simply 4% is increase in kinetic energy. Okay? These problems you have to do like this. And another important concept related to water power energy. Power. Related to power. What are the different formulas? Work by time. ఇంకేమన్నా ఫార్ములాస్ తెలుసా? F dot V power equal to. And again, work ante integration of F dot dx by time. Generally related to power, the problems asked related to efficiency. Do you know what is efficiency? What is efficiency? The ratio between energy or power output to input. For example, 100 joule energy I consume. 100 joule energy I have given. Only 80 joule work is done. Then what is efficiency? Yes, 80%. Or efficiency 0.8. Generally related to this efficiency, problems will be asked like this. "20 kg water from well of depth 20 meters in 2 seconds. If efficiency of motor is 80%, what is electrical energy or energy utilized?" Now it is lifting 20 kg of water from 20 meters depth. I am taking here G is 10 meter per second square. Then what is the work done? mgh, that is 20 into 10, that is mgh. How much I am getting? 4 into 10 power 3 joule. Now what is the power? Work by time kada? That is 4 into 10 power 3 divided by time, 2 seconds. So this is 2 into 10 power 3 watt. But here it is asked, what is energy utilized? Now whatever the energy, what is the work done by this? That is equal to 80% of energy consumed. If it utilizes 100% energy, in that 80% only utilized, this 80% work is this. Then 100% is 4 into 10 power 3 into 100 by 80. Antena? Then how much you get? This is equal to how much? Yes? You get 5 into 10 power 3 joule. This is 100% energy. So what is electrical energy utilized by the engine? 5 into 10 power 3 joule. This type of problems will be asked related to this. Okay? And now let us see some questions from previous papers related to this. Okay, now we see some questions, previous year questions, which are asked in mains from this. Okay, a force x equal to 3x square plus 2x minus 5 Newton displaces a body from x equal to 2 to x equal to 4. What is work done by this force? Here, can I use work done equal to F into X? Can I use this formula? You cannot use it. Why? Because your force is not constant, it depends on displacement. So here what the formula I have to use? Work done equal to integration of f dx and integration limits 2 to 4. 2 to 4. So what I get? This is equal to integration 2 to 4. F is 3x square plus 2x minus 5 dx. Then you substitute what you get. X square integration is x cube by 3 plus 2 x square by 2 minus 5x, and the integration limits are 2 to 4. Now you know how to substitute these integration limits and how to get the answer. Let's substitute them. Then the x cube ఉంది కదా 4 minus 2 cube plus 4 minus 2 square minus 5 4 minus 2 ఇలా సబ్స్టిట్యూట్ చేయొచ్చా? చేయొచ్చా చేయకూడదు? లేదు. First I am substituting 4 cube plus 4 square minus 5 into 2 minus 2 cube plus 2 square minus 5 into 2. Sorry, it is 4. Which one is correct? I have to substitute this or like this. Very correct. ఇలా చేద్దామా ఇలా చేద్దామా? పోనీ ఇలా చేస్తే ఏమొస్తుందో చూద్దాం ఆన్సర్. 4 minus 2 cube. 2 cube అంటే 8 plus 4 minus 2 2 square 4 minus 4 minus 2 2 10 2 joules అని వస్తుంది. ఇలా చేస్తే 4 cube is 64. 64 plus 60 80. 80 minus 20 60 minus 2 cube is 8. 8 plus 4. 8 plus 4 12. 12 minus 10 58 joules. Now you tell me, is this is correct answer or this is correct answer? ఇదే కరెక్ట్ ఆన్సర్. మరి ఇలా ఎందుకు చేయకూడదు? See here. Actually, if I say f of x limits a to b means it is f of d minus f of a. This is the meaning. This is correct meaning. Antegani, we cannot write it is f of b minus a. This is wrong. So this one, 58 joule is correct answer. Okay? Yeah. Now I go to the next problem. Okay, na? Clear? Okay. I go to the next one. Yeah. Yeah, what is the problem? A particle of mass m moves along a straight line with velocity increasing with distance. According to equation, velocity equal to alpha root x. The total work done by the force, all applied forces on particle during the displacement x equal to 0 to x equal to d. Can you do this problem? Here, velocity is a function of displacement. Now, how to do it? Okay, let us start doing it. What is the formula we can take? Work done equal to integration of f dot dx. Can I take like that? No RS. Okay, then what formula I can take? Here, velocity is the function of displacement. It is important. Think. Velocity is increasing with distance. M into A into yes, x. Can I take like this? Work done. Again, what is A? Is there any relation between A and B? Yes, what is the relation? Okay, V by T. Any more? Yes? Again, what is the relation for displacement in terms of V? Yes, x equal to integration of V into dt. Actually, acceleration is dV by dt. X is equal to integration of V dt. Then what is the work done we get? M into dV by dt, integration of V dt. These two will get cancelled. So work done equal to M integration of V dt. Yes? Any more? Can I do like this? Now what is V here? V equal to alpha root x. Then what is dV? Differentiate both sides. Alpha 1 by 2. Yes, root x differentiation is 1 by 2 x square. Is it correct? 1 by 2 root x, which is correct. What is the differentiation of root x? Yes, root x differentiation is 1 by 2. Is it correct? Okay. Now you substitute it. Because it is x, you write dx. So work done equal to m into integration. Instead of v, you write alpha root x dv. Alpha by 2 root x into dx. Root x gets cancels. So finally, from this step, I am writing this step. Work done equal to m into integration of alpha squared dx. The integration limits are from 0 to d, of course, here m by 2. Then you simplify it, work done equal to m by 2 alpha square x limits 0 to d. So you get work done equal to m by 2 alpha square d. Now which is correct answer? Very important thing. This type of problems seems to be very difficult. But if you start from your basic idea, the work done equal to force into displacement, లేదా MAS. అక్కడి నుంచి బేసిక్ ఐడియా నుండి మనం స్టార్ట్ అవుతే, because it is given velocity, it depends on displacement. You try to get some integral form related to the work done. You will get it. Is it okay? Yeah. Shall I go for next one? Yeah. You see this problem. A circular table is rotating with an angular velocity omega radians per second about an axis. See the figure. There is a smooth groove along the radial direction of the table. A steel ball is gently placed at a distance 1 meter on the groove. All surfaces are smooth. If the radius of the table is 3 meters, the radial velocity of the ball with respect to the table at the time ball leaves the table is x root 2 omega. Then you have to find the value of x. Now, this is the circular table, this is groove, and here ball is placed. When it comes to this position, when it leaves this, what will be the force acting on it? In a circular motion, when the body is at this position, what is the force acting towards this direction and towards this direction? Yes? Can I take force is equal to m r omega square? Is it correct? Now this r omega square is nothing but acceleration, centripetal acceleration. So again, what is centripetal acceleration? Right, acceleration in terms of velocity. Yes? Here it is given the radial velocity, v only. The ball leaves with radial velocity. Then you write this in terms of velocity. Now think about it. V dv by dr equal to r omega square. So integration of v dv equal to this. What is integration of v dv? Yes, v square by 2. This is equal to. Now integration of r omega square dr. The integration limits from 1 meter to 3 meter. 1 to 3. So omega square is the constant. This is r square by 2. The integration limits from 1 to 3. So what I get? V square by 2 equal to omega square omega square by 2 r square, that is 3 square minus 1. 2 gets cancels. Then what I get? V square equal to omega square into 8. Then V equal to root 8 omega. Root 8 ante? Can I write it as 2 root 2? Yes. Now what is the value of x? Yes. This is x 2 root 2 omega. The value of x is 2. Is it clear? Yes. Now we go for the next one. Yes. What is the question? A stationary particle breaks into two parts of masses ma and mb, which move with velocities va and vb respectively. The ratio of their kinetic energy. Can you do it? What is given? Stationary particle. It splits into two. It explodes into two. One moves with velocity va, another moves with velocity vb, mass ma and mb. Explosion is because of internal forces, which is constant here. Momentum is constant, conservation of momentum. You take kinetic energy, P square by 2m. Since momentum, P is constant. P is constant. Then what I can write? K proportional to 1 by m. So what is the energy ratio? Ka is to Kb. Mb is to Mb. Now this is the answer. Oh, sorry. I'm very careful. Ka is to Kb is Mb is to Ma. But in question it is asked Kb is to Ka. Then it is Ma is to Mb. Of course, there is some mistake in the problem. K inversely proportional to mass. This is correct. Okay. So your option is wrong, I can say. Here it is asked Kb is to Ka. So your answer should be Ma is to Mb. Either question is wrong or there is no option. But this is the idea. Kinetic energy proportional to, inversely proportional to mass. Because the momentum is constant. Now, you go for the next one. Yeah, this is also the similar question. So what is the question? Yeah. A stationary particle breaks into two parts, Ma and Mb, which moves with velocities Va and Vb respectively. The ratio of their kinetic energies. The same question. Yes. Now you go to this problem. This is also similar, I think. Not similar. A bullet of mass 50 grams moving with speed 100 meters per second emerges with 40 meters per second. The percentage of loss of kinetic energy. Very simple problem. What is the loss in kinetic energy? Of m v square minus u square or v1 square minus v2 square, whatever it may be. Then what you get? Of m. Yes. What is initial velocity? 100 square. Final velocity 40 square. This is loss in kinetic energy. Now you ask it to find percentage of loss in kinetic energy. This is nothing but half m v square minus u square divided by half m v square. Half m will get cancelled. So what I get, this is 100 square minus 40 square divided by, yes, initial velocity 100 square. Can you simplify this? Simply you write 100 square minus 40 square as a square minus b square, a minus b into a plus b. So it is 60 into 100 divided by 100 into 100. Percentage I want. Into 100, that gives the percentage. Into 100. Is it correct? Yes. How much you get? What is 100 square minus 40 square? 60 into 140. That is 100 square minus 40 square. This is 100 minus 40 into 100 plus 40. Now see this. This 100 and this 100 gets cancels. 0, 0, 0, 0 gets cancels. 6 into 14. How much? 84% is your answer. Okay. Now we go for the next one. A body is moving unidirectionally under the influence of a constant power source. Power is constant here. Now the displacement in time, T is proportional to. I want to find